All right, let's get started on this review and look at what's going to be upcoming on the test at the end of this week. So we're starting out with just plain factoring, and it starts with just a 2x plus 16. Remember that the first thing we do anytime we're factoring is look for a greatest common factor. By the way, this is page 260 of the big book. All right, so looking between these two, we could break down these two terms, 2x and 16, into the smallest parts, 2 times x, 2 times 2 times 2 times 2. There is a 2 in common. Left over is an x plus 8. Remember that we multiply out all those that are left. So out in front is what's in common. Left inside from each term. In the first term, there's just an x. In the second term, there's a 2 times 2 times 2, which makes 8. And then the sign in the middle was a plus, so the sign in the middle stays a plus. Here comes the next one. 4x squared and 22x, breaking down into their smallest parts. There's a 2 in common this time and an x. So the 2 and the x go out front. Staying inside will be a 2x that's left over plus 11. If I'm not sure if these are the correct factors, all I have to do is multiply these to get back to my original answer. 2x times 2x equals 4x squared. 2x times 11 is 22x. Now when I look at this next one, I can see that there is a 3 in common in everything. And anytime there's a negative out front, we're going to want to divide out that negative. Another way some students are doing this is by showing the work as division, showing what they're dividing by for the greatest common factor. So negative 3 becomes my greatest common factor, and then we divide that out, leaving us 2x squared plus 5x minus 3. If I'm not sure if this is correct, multiply it out. Negative 3 times 2x squared, yep. Negative 3 times 5x, yep. Negative 3 times negative equals positive 9. There's my greatest common factor and what's left inside. Next, I'm looking up here to see, is there anything in common? I notice that sometimes it's just an x. And so here I'm going to break this down into its smallest parts. And I'm looking for what's in common. This time it's just an x. Left over inside becomes x squared plus 5x plus 3. And there's my greatest common factor in front with the rest left inside. On this next one, let's just do a plain x factoring. What times what equals negative 18 and subtracts to positive 7. So hopefully you're thinking of 2 and 9. And which one gets the negative? I'm going to want to say 9 minus 2 gives me 7. Over here, I can see a greatest common factor of 3 first. The 3 comes out. And then we can do the x in the back. What times what equals negative 10? Subtracts to negative 3. I'm thinking of 2 and 5. Remember that we want to say 2 minus 5 because of this negative 3. When I write out these final factors, the GCF goes in front, then the x plus 2, then the x minus 5. Don't forget that greatest common factor. For this one right here, there is no greatest common factor. So when we have something this big, 6 times 35, remember that you can guess and check, but 6 times 35 equals 210, and then there's a 1 in the middle. So we're looking for two really close factors here that would subtract and give me 1. So take a second to see if you can come up with a something times something that equals each other. Hopefully you got 15 and 14. 15 times 14 equals 210. And so which, up here should be a negative 210 because of that negative 35. So 15 minus 14 equals positive 1, so this one gets the negative. But this time when I write out the factors 6x plus 15 and 6x minus 14, I do need to take an additional step in reducing these factors. So in this one, a 3 can go into both, so 3 into 6 and 3 into 15. This is going to leave me a final factor of 2x plus 5, and 2 goes into 6 and 2 goes into 14, leaving me 3x minus 7. So the final step on these bigger polynomials, or with a leading coefficient greater than 1, is that you do need to reduce the factors. Finally, I'm just going to finish off numbers 8, 9, and 10 before we do a second video for the other part. So for this one, when it's a perfect square like 169, it's just going to be x minus 13 times x plus 13. Remember that the middle term cancels out because of the negative and the positive. Over here is a perfect square trinomial. 8 times 8 equals 64. This time they both have a minus, making a double middle term of negative 16. Finally, an 8 can come out. Oops, I'm sorry. No, a 2 can come out. A 4 cannot come out, so it's just going to be a 2. So a 2 factors out, leaving me 4x squared minus 12x plus 9. What times what equals 36 and subtracts to give me 12? And we'll leave the video here at this time.